In this next equation, we have a radical of x plus 5 equal to negative 8. Since it is a square root, we can undo the square root with squaring each side of the equation. So we're going to take the square of this square root quantity x plus 5 and set that equal to the square of negative 8. Now remember, when you square a negative number, you're going to have negative times negative, or positive 64. On the left side, when you square a square root, you are undoing that radical, leaving x plus 5. Now it looks simple enough to continue solving using your properties of equality. You would just subtract 5 from each side of the equation to get x equals 59. However, it's important to make sure you check and see if that x value actually works. So that means we're replacing x with 59, so we would have 59 plus 5 under the radical. Is that really equal to negative 8? 59 plus 5 would give us square root of 64 equal to negative 8. Well, the square root of 64 is 8. And 8 does not equal negative 8. So let's go back and see if there's some indicator that maybe we should have known it was going to turn out this way in the first place. Notice that when you have square root equal to a negative value, that is not going to be possible. No matter what number we substitute for x, once we take the square root of it, we're not going to get a negative number. If we ended up with some positive number under the radical, the square root of a positive number would be equal to something positive. If once we combined x with 5 and we got a negative number, the square root of a negative number is going to be an imaginary answer or have that complex I involved. It is not going to be a negative number. So right from the start, we should know that if we have an even root set equal to a negative number, we're going to have no solution possible. In our next example, we have an even root set equal to a positive number. So this one we can't just say no solution, we have to work it out. So to work this out, we're going to take the square of both sides of the equation. So that would be the square of our square root negative 7 minus x equal to the quantity of 3 squared. Squaring will undo the square root, so we end up with negative 7 minus x equals 3 squared is 3 times 3, which is 9. So in order to solve for x, it looks like we better add 7 to both sides of the equation to get negative x equals 16. This is not done. This says the opposite of x is equal to 16. This negative in front of x really implies coefficient of negative 1. So to eliminate multiplication of negative 1, we divide each side by negative 1. So now x is equal to negative 16. So we want to check and see if we can keep the solution or if we need to eliminate it. Our check then, anywhere you see x in the equation, you replace it with negative 16. Under the radical, negative 7 minus our x value. This is a little tricky right there. We have subtraction of a negative. Does that equal 3? This is what we're checking. So under this radical, I'm going to really have plus a positive 16. So negative 7 plus 16 makes square root of 9. Does that equal 3? Square root of 9 will simplify as 3, and 3 does equal 3. So we get to keep our solution that x does equal negative 16.